All right, today we're talking about Chapter 5, Section 2, Multiplication and Division of Rational Expressions. This is a super duper short section. I'm sure you care. I know if I was a student, I'd care. I wasn't too privy to long lectures. I am the definition of I have an attention span of 10 minutes tops. All right. So I bet I can just fit example 1 on there, huh? Alrighty, so there were a lot of things that I wouldn't say I necessarily skipped over. It's just I feel like I'm going to cover all this in this example here. But so looking at multiplication property of rational expressions. So if we let P, Q, R, and S represent polynomials such that Q is not equal to 0 and S is not equal to 0, again that just has to be said because we can't divide by 0. Then all right, now again, this is multiplication properties of rational expressions, but this is also the multiplication properties of just rational numbers, right? P over Q times R over S, well, you just multiply P times R and Q times S. And that's it. You just simply multiply the numerators together, you multiply the denominators together. Okay? And then multiplying rational expressions, step 1, step 2, step 3, we need to factor the numerator and denominator of each expression. Again, that is step number 1 of everything that you do in this class, the next class, the next class, the next class, everything. Until you get to the real world, and then you don't really factor anything. But for everything in college, you need to factor the numerator and the denominator every single time. Okay, and then we're going to multiply the numerators and multiply the denominators, and then we're going to reduce the ratio of common factors to 1 or -1 and simplify. What that means is basically just cancel things out. Okay, and of course we'll see that in this particular example. So multiply 5a minus 5b. So it looks like I'm just going to rewrite this, and it appears that I can rewrite this as 5. I can factor 5 out of the numerator on the left, and I'm left with a minus b all over 10 times. It looks like on the denominator on the right, it's a difference of squares, so I can say a plus b times a minus b and over 2. All right, so I factored my numerators and denominators. Let's go ahead and cancel now. So we're going to cancel this a minus b. It looks like this 2 and this 10. Well, actually, that's the case. We can actually say this 5 and this 10. And that's actually a pretty good point. Okay, so I'm going to factor the 5 and the 10. So that becomes a 1 over 2. Okay. And then from there, the 2's cancel, right? So my end result is going to be, it looks like, just simply 1 over a plus b. Okay, well, what if I went ahead and I did factor the 2 first? Let's just check that out instead, okay? So if I did this, that turns to a 1, and this turns to a 5, okay? Well, the 5's cancel, and we're still stuck, and we're still left with a 1 over a plus b. So in either case, it does not necessarily matter what you cancel first, as long as you do your canceling. And that's it. That's it for example 1. We just factored, canceled, and that's it. Ooh, this one. Ugh, ugh. Oh, that's bad. Bad stuff. This is one of those examples where I can easily screw up, and it's super embarrassing because it's on YouTube now. But here we go. So I'm going to factor my my top left one here, right? The numerator on my left side. It looks like I can factor out a 4. So I'm left with a w minus 5p. Probably made it a little too big. Oh well. And then the denominator, it looks like I can factor out a 2. So I've got a 2w squared minus 25p squared. Right away, I can tell that this is a difference of squares, so that's good. So I'm going to be factoring that. Times the top right, or the numerator of my right fraction. It doesn't look like I can factor anything out, but so that means, unfortunately, I'm going to have to do the AC method. Okay, but before I do that, let's go ahead and let's factor my denominator here. It looks like I can factor a 3 out, so I've got 3 and then w plus 3p. Okay, so I'm going to have to factor the numerator of the right side here. And yeah, I'm just going to have to do that. All right, so here we go. 2w squared, so 2w squared plus wp minus 15p squared. All right, and again, I'm doing AC method here. So a times c, which is equal to my a value here is 2. My c value here is negative 15. So 2 times negative 15 is a negative 30, but I'm just we'll put that in absolute value symbols because I mean what I'm trying to do is get to 30 here. Here's why. I could have wrote negative 30, and there's nothing wrong with it, and obviously it is a lot more precise. It's just if I were to say what are my factors of negative 30, I could say 1 times negative 30, or I could say negative 1 times 30, right? And instead of writing that twice, I'm just going to go straight ahead with what are my factors of 30. Okay, because if I do that, then I'm going to just simply say 1 times 30. So 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6, and then 6 times 5. Okay, so next what we're going to do is we're going to say, okay, so what are, and again, these are my factors of 30. Of my factors of 30, which ones, when I add or subtract them together, will give me a 1, right? That's an implied 1 right there, okay? What will give me an implied 1? Well, there's no combination of 1 and 30 that will give me a 1, 2 and 15 will give me 1, 3 and 10 will give me 1. However, a negative 5 and a positive 6 will give me a positive 1. So negative 5, positive 6, so we can rewrite this now as 2w squared, and we're going to say minus 5wp plus 6wp minus 15p squared. Okay, so again, if we agree that wp, all right, that's the same thing as saying a negative 5wp plus 6wp, right? Again, it's just 1wp, right? So now once we did that, we can factor by grouping. So again, just split right down the middle. And this should work 100% of the time, every single time. The only difference that you might run into is instead of factoring out a positive number, you just factor out the negative number. That's it. So anyways, the left side here, what can I factor out of the left side? Well, it looks like I can just factor out a w. That's it, just a w. So I got 2w and then minus 5p. Okay, what can I factor out of the right side? Well, it looks like I can factor out a positive, so a positive 3p. And what remains looks like a 2w minus 5p. Perfect, that's what we want. And then this ends up being 2w minus 5p and w plus 3p. Right. So there, I factored that. So let's put that on the previous page again. So 2w minus 5p. So 2w minus 5p and w plus 3p. W plus 3p. All right. It appears, all right, so I I didn't factor this completely, so let's go ahead and do that now. Okay, so w squared minus 25p squared, again, that's a difference of squares, so it's just going to be w plus 5p and w minus 5p. Okay, so I'm going to put that up there. W plus 5p, w minus 5p. And now let's do the cancellation process here. So it looks like w minus 5p, that cancels w minus 5p. It looks like w plus 3p cancels w plus 3p. Well, I guess this 4 turns into a 2. This 2 turns to a 1. And so it appears we're just going to have 2w minus 5p all over w plus 5p. W plus 5p. Oh, I forgot my 3 over there. This 3 here. So, I forgot my 2. Okay, got ahead of myself. Okay, so I've got a 2. So 2, and then 2w minus 5p. That's my numerator, so I took care of the 2 there, and then this, so that's good. All right, and then I've got a 3, so 3w plus 5p. I don't know, I feel like, let's see, so w plus 5p. Let's see. And that's what we have here. Oh, that's good. I was a little nervous there, mainly because again, like I said, this stuff gets very tedious very quickly, and making a mistake on YouTube just sucks just a little bit. But no worry here, we got it. And then last example, division. So division is honestly, it's not the same. There's just one little thing you have to do first, and that's just simply flip it around. So let's show you what I mean by that real quick. And actually, let's give this its own page, because there's going to be lots of computation. But before we get there, let's look at this, the division property of rational expressions. So here we go. Let P, Q, R, and S represent polynomials such that Q is not equal to 0, R is not equal to 0, and S is not equal to 0. Then P over Q divided by R over S is the same thing as equal to, let's make this a little bit larger. A lot a bit larger. So P over Q divided by R over S is the same thing as P over Q times S over R. So we are changing the division sign to multiplication, and then we're just flipping the fraction. So R over S turns into S over R, and then we just do the multiplication that we did on the previous two examples. And that's it. So for this example, right, and for the record, this is something that you're going to be seeing a lot, and I will say this much. I have calculus students that see a problem like this okay, I see a problem like this, which is the exact same as this. It's the exact same. It's just no division sign. It's just this big old long division line there. They'll look at a problem like this and go, okay, no, I don't know how to do this. I'm done. All right, but it's just a fraction divided by a fraction, or if we write it like in this example, we can solve it super duper easily, like we're about to see here in a moment. Okay, so what the thing on the previous page said is we can take the equation 8t cubed plus 27 over 9 minus 4t squared. And instead of having a division sign, we can multiply, and then we just flip the fraction. So 2t squared minus t minus 3 all over 4t squared minus 6t plus 9. And am I doing that? There we go. Okay, I guess I was. And just kind of I wouldn't necessarily say a pro tip here, but um, I write my t's, as you can see, with a little hook on them to differentiate from my plus signs. But as you saw there, for some reason I was putting just a little hook on my plus sign. That's just it happens, right? But just put a little hook on your t, and I don't know, it really help you differentiate what you're doing there. But anyways, that was the I wouldn't say the hard part, but that was really just the only thing new here. Oops, that's not what I want. That's really the only thing new here is multiplying by the reciprocal. Certainly you've heard that phrase somewhere, maybe by me. Again, I forget what all I've taught right now. But there's a solution. It's nothing different from the first two examples. The big takeaway is just simply multiplying by that reciprocal. Anyways, that concludes the lecture on Chapter 5, Section 2.